morning, everybody, and good afternoon, good evening if you're in other parts of the world. My name is Jason Dablow, and I want to thank you so much for your attendance this morning. Just real quick in terms of some housekeeping items about the On24 platform. You do have the ability to resize the slides in the middle of your viewing pane in the bottom right corner, I believe it is. You also have the link to speakers, both myself and Robert, in the under the speaker section with links to our LinkedIn as well as our bios. And then, of course, we want to keep this interactive. We do have some slides with some polling information. Just go ahead and click on the poll when that comes up. But we also have the ability to ask questions. So please feel free to use the Q&A section as we're moving through this presentation as well. So for this presentation, we're really focusing in on really the title is essentially security mechanics and frictionless implementation for a DevOps world. There's a reason why that quantum is in there, and we'll talk about that a little bit in the future as well. But really, we're really focusing in on really how to make security and DevOps work really nicely together in terms of both process and tooling that you might use within these types of environments. And then certainly following that up with really how to create a frictionless environment in terms of integrating security with a DevOps pipeline as well. So there'll be some demo at the end, which will give you an idea of how this is actually put into action as well. So as I mentioned, my name is Jason Dablow. I'm a cloud security advisor here at Trend Micro. I share lots of information on LinkedIn that allows really people to stay up to date in different security news and things like that. So feel free to add me again. My link to the LinkedIn is on the left under the speakers. And then, of course, I'm here with Robert. Robert, why don't you go ahead and introduce yourself as well?
Hey, good afternoon, everybody. I'm on the East Coast. Robert Murphy here. I'm the head of delivery and engineering for Mphasis Stelligent. We're a DevOps organization, specifically on AWS. My background is software development, particularly in the big data and data ops space. And for a number of years, I've been a DevOps automation engineer. So I've come to bring that experience into today's presentation. Welcome aboard.
Yeah, thanks, Robert. So why don't you start us off with, you do have lots of experience in terms of, DevOps and automation. Maybe you can kick us off here on terms of why DevOps? Why is this important to, our customers out there?
Yeah, totally. So I definitely want to set the pretext here, like what DevOps really is. It's a combination of technology, process, and ultimately company culture, right? So we want to not only bring in tools and policy and ideas, but also empower teams to be involved in that process and implement change on their own. And supporting that idea comes automation, infrastructure as code, building security as part of your pipelines, continuous delivery. Let's deploy things as fast as people can innovate. Again, empower your team. We want folks to feel comfortable taking an idea from their brain and putting it in production right away and feeling confident in those decisions, which means speeding up the feedback process. We want to know within minutes if an idea is viable in production and get it deployed if it is. And finally, very pointed into security are ATOs, right? How do we connect the security side with our continuous delivery pipelines to make sure everybody's comfortable and that, regulated industries are all taken into account when we do this high performance development style?
And I think that continuous security is a really important point here as well. I have the pleasure of, working with lots of enterprises here on the West Coast in terms of going through either a digital or DevOps transformation or, working on a cloud migration or something similar. But ultimately, as they're kind of going through and trying to implement these DevOps processes, I learned something really interesting along the way is that, I would say maybe 4 or 5, maybe even 6 years ago, there was the hottest term was DevSecOps. DevSecOps. Everyone was saying DevSecOps. And then all of a sudden it went away. So a lot of the companies I would talk to were just saying DevOps instead of DevSecOps. And naively, I just assumed that everyone was doing security and it was baked into those DevOps processes, and that's why they just kind of dropped the term security. But what I actually ended up finding out is that most companies were just accelerating as fast as possible and often leaving security back because it's often seen as a challenge or a waterfall process. We'll talk a little bit about that more in the future as well in terms of slides that are coming up, in terms of really why that security becomes or has traditionally been in the past a kind of a roadblock or a slowdown in terms of the DevOps process. But ultimately, you know, even though the DevOps is kind of the most used phrase, I always say like the S at the end is now the security, right? So while DevSecOps is certainly the thing here, and making sure that we're implementing security policy as a change within the environment that can be tracked and versioned and tagged and all of that really important information, you also have the requirement to really bring in security into these really fast, agile processes in terms of automation for not just the policy, but also your automated testing as well. So we want to make sure that as security professionals, as our teams are going through this DevOps transformation, you know, Robert touched on it, as a cultural change within a company. It's not just accelerating one application delivery, but it's actually incorporating all different types of a business and making sure all of that is accelerated and giving feedback as quickly as possible as well.
Yeah, exactly right. We have a trope here that we use a lot at Stelligent when we talk about DevOps that I think applies here, right? And that is that your infrastructure and your automation code is just as important as your application code. So it should be committed alongside the application. That's no different here. Security, policy, and tests and all the automation and infrastructure that goes along with managing these regulated environments can live with your application code and are just as important to be tested. In the same note, like your security team, your developers, your operations people, anybody should feel like it's okay to commit changes to that ecosystem and let your automation and your pipelines take care of the rest. And that kind of goes in.
Sorry, go ahead, Robert.
Yeah, I was going to say that kind of goes into throwing it over the wall, right? Like we're breaking down that barrier of security, implementing a change and, you know, saying you must update these 1,000 servers to do this thing now, and setting it up so that way they can just go into the code, make the adjustment they need, initiate a pull request, and the whole team can review it as a collective. And you're not throwing work around, you're just collaborating. What were you going to say?
That's a key point. That's a great key point there in terms of that collaboration as well as that automation of the security policies. So you have these teams that are actually working together. So once that wall kind of comes down and you don't have, say, an InfoSec team that comes into a development pipeline and says, you must enact, you know, these firewall rules or make sure that everything has, you know, anti-malware on it. You know, there's some key points here in terms of, while that was the old strategy when that wall was still up, but now that it's down, we need to treat, as security professionals, we need to treat these DevOps pipelines in a way that they understand in the way that they're building their applications, and that's really as code. As Robert touched on, what we can do is actually submit things like bug fixes for infrastructure that's being built by DevOps. And in, say, that bug fix or bug tracking, what you do is essentially give them the tools to create security policy or create the security protection that's required within these environments using a same bug tracking mechanism that they would within their applications or software. So you're essentially communicating with these teams in a manner that's efficient and agile, just like these DevOps processes that are being implemented. And ultimately, because we're now tearing down that wall and bringing in security much faster and much quicker and easier into these DevOps teams by, again, treating it as code, you're really reducing that friction. You're really empowering these teams to actually own security because it actually helps them deliver value to their customers as well. What you see, the image at the bottom there is kind of that tie-in into quantum mechanics or quantum levitation. This is a maglev system where you would essentially supercool a magnet. And what happens is it will essentially spin around this track and it's essentially levitated based on the magnets. And it really allows a frictionless cycle to occur. So they've been doing a lot of experiments with this type of technology in trains, as well as other types of things to really reduce that friction. And so that's the tie-in with the kind of that quantum in parenthesis in the title, is really creating these frictionless environments and teams where you have security that's baked into processes earlier on within that development cycle.
Yeah, exactly right. I want to touch on a couple points there, right? The main goal here, especially in larger enterprises, is it has to be repeatable. And if you have people involved in the process as part of the whole thing, where you're sending, large change sets to engineers that have to be manually put into an issue tracker and executed, like that doesn't scale very well. It costs a fortune. And that's where these tools really bring the power. You put it in code, you offset that people part into automation and tie in your Slack channels, and you bring the costs way down and you increase the effectiveness by 1 billion%, And I'm being crazy with my number there, but it's significant. I also want to say, what makes this work is confidence in your continuous delivery pipeline. If you have good tests and your acceptance environments are working, then you can trust your security team to test a firewall change, right? I know when I heard Jason say, let's make a firewall change, immediately I shrink up and go, oh man, that could break something in production. If I'm confident in my test suite, I'm gonna know before it gets there, and that opens up a conversation for us to negotiate the policy, which I think is where the shared responsibility model really comes into play, right? We want to separate who does what and where we work together. I think in an ideal model, the security team, the InfoSec team, implements things on the cloud as a whole. So they focus on policy development, auditing, obviously enforcement, they're the buck stops there kind of group. And also selecting tools for the entire organization to use. Your DevOps team focuses on security in the cloud. They're very focused on their single application and how they fit into the bigger picture of the enterprise. So they're automating those configurations. They're setting up remediation such as rollbacks or roll forwards and implementing the tools that kind of get agreed upon between the two. The goal is continuous security, right? The security team will always want to lock everything down. Their ideal situation would be to unplug all the computers and turn them off and put them in a room somewhere behind lock and key. But
that might be a little unfair. But
well, right, a computer not connected to the internet isn't exposed to risk. But the business requires us to negotiate that. And I think that's kind of where a nice shared responsibility model helps us figure out who does what and where the accountabilities lie.
Yeah, I think they have that saying of the only secure computer is, turned off and sitting inside of a Faraday cage. But also, you brought up a great point, Robert, that's often overlooked, I would say, from a security engineer's point of view, is that, availability is one of the core pillars of security. And when you're talking about availability, you're also talking about the introduction of the security policy into application pipelines, as well as the availability for, ultimately your customers to access this application, or, internal, whoever the actual customer is, ultimately making sure that that application is available to them. This shared responsibility model, I'm sure a lot of you on the phone have seen this when it comes to cloud providers or something similar, where you have a kind of that line of responsibility, whether it falls under you as the customer, the cloud provider, or the cloud provider itself, in terms of providing that secure infrastructure to build into. But, Robert created this model in terms of a shared responsibility between, DevOps and security. And I think it's kind of one of the really key pieces here in terms of, the content around this is really having that feedback between these two teams, between InfoSec and between DevOps teams, to making sure they come to an agreement on, things like the policy, and making sure that the application is ultimately available. It's one thing that one of my customers here in Southern California has actually implemented in a wonderful way. So much like that shared responsibility model, they have a global InfoSec team that defines the policy, and a DevOps team that essentially implements it. They get to actually choose their own tooling. This is a large financial customer here in California, and it really allows them to basically automate the security implementation, which again, we're going to talk about in a demo in just a little bit, but also allows them to control the infrastructure as code, and letting the development team, which is ultimately a little separate than the DevOps team, they're kind of like if you think of it as the automation team of bringing the application from developers into a runtime environment. So that's their responsibility within their team set, is really implementing and integrating security directly from a DevOps point of view by using automation techniques, testing their security much like they would in production, but also doing that in a dev test phase. So by automating your security testing and automating whether it's your red team activities, not just in production, but also development, it really allows them to be more agile with those changes. And it allows them really the ultimate ability to say, take the security policy from the InfoSec team, and then by working together with that team, they now can feedback in terms of what their application teams require, what security actually needs to be implemented as directed by the InfoSec, but ultimately they have control over these workloads to really accelerate that value that they're delivering to their customers across a very large container environment. You're talking over 10,000 containers in this particular space. So again, it kind of gives them the ability to accelerate the delivery of value to a customer, as well as the security around it. So the application is doing only what it's supposed to do. And that's kind of like that definition of a breach, right? If the application starts doing what it wasn't intended to do. So the application should only do what it's intended to do, and that's the only thing it should do. So I think that's a great principle in terms of a customer here that's actually implemented this security within their DevOps teams, taking ownership within this DevOps teams to ultimately accelerate that value they're delivering to customers. Robert, I know you've worked with a number of customers too. Can you share a little bit about what you've seen as well?
Yeah, totally. My favorite use case for continuous security comes from my public sector background. Most of my consulting experience has been working on government projects, modernizing things. And I want to say about 2 years ago, I worked on a project where their process for security was once a month or so, they would send our team a 1,000-line Excel spreadsheet that listed all of our servers in the AWS cloud and what policy they were violating. And the expectation was for us to immediately jump on that and resolve, which never happened. I mean, if we got 50%, like, we were amazing. And what we did is myself and a colleague kind of took a step back and we said, how can we make this automatic? And what we ended up coming up with is integrating that spreadsheet through the APIs of the tool that generated it into the pipeline and just setting a threshold that constantly moved, right? So we started at maybe 1,000 open issues. And then every couple of weeks, we would adjust it up. Let's get to 900, then 800, then 700. And by slowly chipping away at it, we finally got to a point where we did the best that is possible is done. And when we did future applications, we were already 10 steps ahead because we were ready to go because we had the automation code already written. And if you're familiar with government stuff at all, they have this concept called an ATO, which is common in all regulated industries, where in order for you to launch a product into production, you sit at a big table with all the senior stakeholders and the CISO, and you work through what your QA and your security stance is. And to be able to go in that room and say, like, we're 100% compliant is just a mind-blowing concept. And that was something that, like, we triggered a cascade effect in that organization by being that example. And it's brought a lot of success to Mphasis Stelligent in particular because our customer knows us by name because we triggered that. And future projects we've done, we get ATOs automatically. There's just that trust. Everything's automated. You know, if the security team needs to make an adjustment, I've seen them submit PRs into our applications. Like, that's crazy. Who's heard of that? And this tool that we're showing you today is one step closer to doing that in your company.
I think we'll open it up to a poll now for those of you. If you click on one of the options here in terms of a cloud strategy that you currently have in place within your organization, we'll just kind of touch on this in just a little bit in terms of really a sample environment right before we go in through the demo that Robert's going to go through. So really the poll is just kind of learning about your current cloud deployment strategy. Have you chosen a cloud yet? Are you in AWS? Have you gone multi-cloud? Have you not delivered any workloads yet into a cloud environment? Certainly this is kind of really interesting in terms of some of the services we'll be talking about you know, in just a short while. Things like AWS CodePipeline, and some of the others AWS services that are out there as well. I just wanted to take a quick second here and a quick poll for really just to kind of gather some additional information on how you guys are really deploying today in a cloud environment, if any. So it looks like we have even split. I like that. So we have multi-cloud and other cloud in terms of differing in terms of where they're actually doing deployments. I see that a lot in terms of the customers that I talk to, and with ultimately the multi-cloud as the kind of chosen method, particularly for larger enterprises, so they can not just, I would say, as they're going through acquisitions and different technologies that the different teams might be using, but also I've seen it as, you know, kind of price structuring, you know, against the different clouds to be able to, you know, rotate if needs be in terms of, you know, availability or cost optimization as well. So ultimately here, I'm just kind of presenting here a sample multi-security layered architecture using Trend Micro technologies, and certainly using as a guide AWS here as well. So everything on the left is really what we've been talking about, and I know this slide is one of the busiest that I've ever created, but it just flows left to right and then kind of forks and goes all over the place. But starting on the left there where it says developers, this is really that development team as they're writing their code, pushing that new code version into a code repository, might be managed by AWS CodePipeline, and then ultimately putting the code together in code build. This is really interesting here in terms of adding a layer of container security to do your image scanning prior to it launching into runtime. So you see kind of two different forks here, pushing it to, say, container security for that scanning, or pushing it directly into the registry, which ultimately the Cloud One container security can reach into and scan as well. We'll be talking a lot about this particular solution, the Cloud One container security. And ultimately, as it reaches runtime, you now have the ability to say, if it's deployed to, say, EC2 instances or a server environment or anything running Docker or just plain hosts running EC2 instances, you have that workload security here that allows you to protect that. And should you be deploying into things like a serverless environment, for example, Lambda or AWS Fargate, you optionally have the ability to add additional security controls here using the Cloud One application security as well. Both of these technologies are focused on bringing not just anti-malware, but also intrusion detection, intrusion prevention, that vulnerability shielding for any of these applications as well. So they're really application focused. But ultimately for this talk here, I would say that the bottom piece is this most important. So what you see is in your runtime environment, you have the information that a security team needs in terms of what they need to react against. So this might be flowing into their SIM so they can do their collaboration there. They can correlate all the different events that might be happening. And you also have this optional channel of Slack that allows you to, again, get real-time collaboration and communication for your teams as well. Slack can also deliver the same information to the development team or kind of make it more pertinent in terms of, is it something that was built via application as code that's pushed through the same methodology of using the code repository. And ultimately what you can do is also integrate with something like Jira. And again, this is what I was talking about earlier in terms of creating those the bug tracks. So the same methodology that a developer would use in terms of tracking their bugs through version control and case statistics and bug tracking, do the same thing for security events that might be happening and can be fixed and resolved through this DevOps pipeline as well. So if a change needs to be made in, say, infrastructure as code, which affected how the application is built that opened up a security hole, you can just create a bug fix for that same team that manages the infrastructure as code and ultimately solve that security event in the same manner that they would within an application problem. And that's by just squashing a bug within this particular environment. Anything you want to add here, Robert?
No, I don't think so. I think I'll cover my points as we talk about the demo product.
Yeah, and I think we'll go into that right now. Yeah, please.
Yeah, perfect. So we put together a demo. It's blogged about on our website on Stelligent, which the link is available to you in the webinar tool here. And I wanted to walk you through how you can run this demo right now. You can follow along if you can type fast enough and set this up and see how it works and start playing with it. The demo is launching the Trend Micro Deep Scan Security Check tool on AWS using CodePipeline. The infrastructure is fully automated, so it's a one-click deploy. You launch some containers on Kubernetes, and you can see security results right away. The idea behind this demonstration or this sample piece of code is any engineer, whether it's from your InfoSec team or your DevOps team, can deploy the infrastructure and deploy the tool and manage it through code. And your engineering teams, your developers, whomever, can commit code and trigger your pipeline to execute the scans and then take remediation. In our example, our code pipeline is configured to stop and wait for a manual approval override. So as I walk through the demo, you'll see we'll commit some changes to the container. It'll trigger the webhook. DSSC will scan it and ultimately stop the pipeline from deploying this into production, quote unquote. As a bonus tip, and I won't charge you for this one, never do live demos on a webinar. because they will most likely fail for some reason. So what I did was I took some screen caps of what I did earlier. So you can run this demo right now by cloning the repository off GitHub. It's AWS Trend Micro DSSC. There's a number of make commands that you can run to set up the infrastructure. So when you run deploy cluster, deploy DSSC, and ECR, you're going to set up some CloudFormation stacks that set up an EKS cluster using Amazon EKS, as well as the DSS tool deployed on top of it. And that'll give you an endpoint that you can get to DSSC with, and you have the base infrastructure for pushing containers into the AWS cloud. It does take a few minutes for this to run, but there's no manual configuration required. Next, we're going to deploy the AWS CodePipeline and ultimately the container that we're going to run through the scan tool. Just 3 commands for this: build and push Docker image, which sends out a sample container into ECR. Deploy webhook configures GitHub to be able to trigger the AWS CodePipeline to initiate its deployment process. And then deploy pipelines of the CodePipeline. Again, these are all CloudFormation stacks. You'll see them create in your account. So when it comes time to tear all this down, when you're ready to do this for real, you can just delete these stacks and your AWS account will be clear of all recurring costs and infrastructure. Oh, we've got a poll here, Jason. Tell us about the poll.
Yeah, so you mentioned AWS CodePipeline. I wanted to just kind of set the stage here in terms of the coming up architecture that you're going to describe in terms of what this builds in terms of an AWS resources. So to start, we mentioned AWS CodePipeline. Are people familiar with this service? Are they familiar but don't use it? Or are you already using it within your environment? I'll give you just a couple seconds here to tally the votes, and then we'll move forward with that demo and show off kind of the resource and architecture that it builds, including the AWS CodePipeline. So it looks like a large amount is not familiar with, and some are familiar but don't use it. So essentially, the CodePipeline is a integration tool that can help really manage a software pipeline. Think of it like if you're running either on-premise or a SaaS version of something like Jenkins, or there's other tools out there like Travis. So ultimately, it's a software delivery mechanism that allows you to really start putting together those CI/CD pipelines. So Robert, why don't you tell us more about the architecture that was built within by these CloudFormation stacks and what this might look like within their environments?
Yeah, absolutely. And I just want to add to your CodePipeline intro there. If you're working in the AWS cloud and you're building continuous integration or continuous delivery, CodePipeline is a great choice if you're doing container deployments or serverless deployments. The interface between those two services in AWS are practically seamless, and you will save a ton of time over using something like Jenkins or like BuildBot because you're not having to reach out to third-party APIs. So the infrastructure for the demo, we set up an ECR, which is just a Docker repository in the AWS cloud. There's a CloudWatch alert that triggers CodePipeline to pull from GitHub. Code build triggers, which builds the Docker container and pushes it into ECR. There's an API call that triggers DSSC to make the scan of the new container image. And then there's some automation code in the CodePipeline, which you can look at in Git. You can see the commands that are run. But essentially, we query DSSC to say, hey, what vulnerabilities are in this container before we deploy it? And then we make a simple ternary decision like, are we good with this or not? If we're good with it, then it deploys into EKS. If not, it gets rejected and the pipeline stops. There's a manual gate there that we put so you can kind of play with it. Maybe you want to override the vulnerability if it's something, not important to your organization, or you have an important deadline, or, a business decision that gates it otherwise, just to show that there's options available. It's not a hard stop. But yeah, it's pretty simple. This is something that you can copy and paste and run with in your org, especially if you're already on CodePipeline. So here's what the DSSC tool looks like. As you can see, I pushed a container. Actually, let me take a step back. So I pushed the first container, which was clean. There was no issues with it. It's a very simple demo container. Then what I did was I injected some malware into the container and pushed it again and triggered the pipeline, which you can see on the second note here, there's multiple vulnerabilities in that second push. What that looks like in code, and this is what's really important as you implement this in your continuous delivery pipelines, is you can get just a binary answer like, hey, is this thing good or bad, by getting the pipeline result directly from CodePipeline. You can see it returns a proper exit code. Or you can call DSSC directly and say, hey, what exactly are the vulnerabilities? And it will list out every single issue you have in great detail, as well as a summary, which you're looking at here. And you can just run off that. Say, hey, if I have more than one critical vulnerability, stop the pipeline, or high or medium. You can adjust it however you like. What I'd recommend is what I mentioned earlier, especially if you're starting off on an existing workload. Maybe set the vulnerabilities to what you have today, and then set it to slowly scale it back until you get to 0. So it's like when you introduce unit testing into a legacy code base. You're not going to get everything 100% on the first day, but maybe you can slowly chip away at it and get it to 0. And this tool allows you to do that. It's pretty cool.
I think the
in your AWS code.
Here, sorry, Robert, if I could just add just a little bit more context in terms of the previous slide, actually the last two. When you're talking about this also, this kind of follows that split methodology in terms of actions, right? So now you have a UI that shows all of the findings for, say, the security team that's used to managing UI consoles. It's similar to my customer. They have the InfoSec team that's using the console to log in. However, the DevOps team is just using these scan results, particularly this type of information, through a webhook that then stuffs it back into their pipelines as well. So now, based on the projects that your DevOps teams are building or trying to deploy, and the findings that you get from, say, a container that has a vulnerability or a piece of malware in it, you now have the ability to fix that within the build pipeline. But not just that, but you also get the visibility of these problems within the same project management tool, in this case, AWS CodePipeline, that you would as like normal deployment information as well. So now you're getting not just information about your application deployment, but also the security that's involved with it. Again, using that same exact visibility tool that's just now stuffing the security information into that project. So now you ultimately get visibility through both as well. So sorry, Robert, I didn't mean to cut you off. I just want to add a little bit more context in terms of how my customer is using this kind of setup as well.
No, I'm glad you interrupted me, because I would have just kept going. One team, one dream. What you're looking at, yeah, man, what you're looking at next is what the code pipeline will look like when it fails. So you can see here, I pushed that malware, security scan came through, we said, no way, Jose, and then there's a manual approval for it to continue. This is what you want. You want the build to stop if there's a critical vulnerability in your system, maybe on a new day. So automate it. And that wraps up the demo. I highly encourage you to check out our blog posts on the Stelligent website. It has the links to this code, the step-by-step walkthrough, even in more detail than I've covered with you today. Check it out on GitHub. It's ready to rip. Run it in your organization, and you'll love it. The blog post was originally written by Sean Aucoin. He's a Stelligent senior DevOps automation engineer. So make sure, like, I didn't write it. He's the guy. He's awesome, part of my team. And
yeah, we worked together. Sean and I worked together in terms of, he did all the work. I just kind of provided some intelligence on the Trend Micro tooling. But ultimately, those two links are also provided in the resource section. So if you click at the bottom, there's resources there. Both those links are available to you if you want to run this within your environment as well. Ultimately, that's the content we wanted to present today. Wanted to open it up to any questions. There's that Q&A box. You can go ahead and type them in. But ultimately, for those that attended live, we will be sending out a gift for you for attending today. And also, as a follow-up, if you would like more information on really how Stelligent and Trend Micro work together in terms of automating security pipelines, we've done a number of projects together similar to this particular demo and using some other tool sets as well. Stelligent's an amazing partner in terms of automating pipelines, and Trend Micro, we are the leader in terms of threat research and cloud security specifically as well. So as a follow-up, if you'd like to book a meeting to hear more from either of us or present together as well, ultimately reach out to us and we'll have a follow-up gift for you as well. So we'll do that through the end of October for those of you that are on the phone live as well as those watching this recording. Feel free to reach out to book that demo, and be happy to have a follow-up gift if you do it within the end of October as well. Anything else to add, Robert?
no way, you covered it. Thanks for the kind words. We enjoy our partnership with you as well.
Yeah, absolutely. Great company, and from the projects that I've worked on with Stelligent, they're an amazing shop that really leaves behind all of the code that they've written, but it's also clearly labeled with comments. Just an amazing partner in terms of providing the automation excellence that they do. And then, of course, with the Trend Micro tooling, really making sure that they can pull the most value out of it for customers that are implementing it in a DevOps fashion. So with that, I don't see any questions in the chat. I'm never one to have canned questions. But it always feels like I purposely left out something that I wanted to talk about. And ultimately, they're hard to come up with. So with that, for me, Jason Dablow from Trend Micro, thank you so much. I appreciate all your attendance. And for those listening to the recorded session, be sure to follow up for that demo and that gift as well. Robert, I'll leave it to you to close us out. Maybe like a fruitful thought or something that we can close on a positive note.
Oh man, you're putting me on the spot.
I did.
Automate everything. That is the closure of today. If it can be automated, it should be done. No manual gate. Happy coding.
Appreciate that. Thanks, Robert, and thank you everyone for attending. Enjoy the rest of the day and have a great long weekend.